Okay, today we start with a new chapter in VFX, which is using fluids. With the fluids, we can create some magical smoke, we can create some steams, gas, and by using fluids, we can create these interesting effects, which called like magical smoke. This magical smoke will be our next task. It is also when you create effects only, you will earn 4 points. If you render this, you will earn additional 2 points. And this is an example from the internet of creation such effects. And also we have in these YouTube examples our students' works. You can also upload your works in internet, and everyone can see your task. And next, this one is also from our students. You can set up your environment and create this slide magical smoke. And let's check everything. Everything is recorded. And also you can create magical smoke by using fluid effects from Maya and by using Bifrost. We are going to use some fluid effect, just fluid effect. Also, I'm sharing with you some tutorials. You can use them, or you can use my tutorials for creation these effects. This magical smoke effect is really interesting and useful in visual effects, and you can try to create your own. This one was created in the Unity, but also the common vibe is the same, and you can create something magical. And during this effect, we are going to use not only fluids, but also some particles. I think we watch everything for the magical smoke, and let's see works from previous year, if I have some. This is example of the rendering. What? Okay, let's check examples from the previous year according to the magic smoke effect, and let's see results. Some of them create some interesting variants of this magical smoke effect, and you can create something according to your sense of creativity. The sense of humor is also great if you add something interesting. Today I'm going to create some magical smoke effect from our TEDs 2. Maybe it will be some impact, I guess. Uh, I'm faced with this idea when I walk through the streets and see how how much smoke we have from these tubes. And this one is also interesting. And we are going to create something like this. Uh, Maybe I'm sharing with you my reference for this TEDS 2 example. Okay, here is my idea for today's lecture. Let's create something new and with some magical effect. Maybe we are going to create like this. Okay, let's start. Let's start with the fluid effects. Um, Fluid effects have the same steps for creation. It is some emitter, which is emit some fluids. Fluids, it's like a texture. It's like small particles with this cloudy texture. And we are going to create the simple fluid with one emitter. On the next lectures, we are going to create some difficult fluids for the portal effects, but today we are going to start an introduction with the fluid effects. Previously, we was used some particles. Now we are going to create some 3D fluids. We need some container, and we also can create some 3D container, and we need to open some settings and check does it add emitter inside in this container. Let's create, and now we can see this fluid effect. If your textures or shading is not selected, you will see this effect. If you select this shading mode, you can see this small steam. For the fluid simulation, we need a lot of frames. Maybe we are going to use 500 frames because we need a long time for this slow simulation of the steam. And now if we add some more frames, we can see how this emitter starts fill this container. For this container, we can change some settings. Let's open attribute editor, and we can change after resize. If we put this selected, it means when we play, these teams go directly and to in the infinity, and only number of frames decided how long this simulation will be. For this, for example, simulation, we are going to use after resize container and leave this fluid go away to the infinity. Only need to change our after resize threshold. It will be just a little bit more, a little bit less for these settings. And next, I'm going to increase this base resolution. The quality of fluid depends on this base resolution. For example, now we can see this container consists of these small squares at the bottom of this container. And if we increase this base resolution, the number of these squares is increased. And now we can see much quality simulation. But if we increase this base resolution even more, our system can be very slow, and we need a lot of power of our computers to simulate the quality of this fluid effect. That's why we need to keep this base resolution as much good as we can, but not so great. And next, we also can change position of this fluid emitter. We can put it down at the beginning of the simulation. And let's start settings for this fluid effect. We are going to create some magical steam. For these magical steams, we can use, we should open fluid shape and go to the dynamic simulation, to the content details. In the content details, we have a lot of settings, which is density, velocity, turbulence, temperature, fuel, and color. By using these settings, we can create from this fluid effect magical smoke, even explosion, even just small smoke from the cigarette. And by using the settings, we can change the character of the simulation. And also we can put it somewhere up and put this emitter down. And let's check. Let's check if we increase some bias. Now, for now, this bias is 1 by the default. Let's increase it for 2 and see what happens. Now it starts smoky at the beginning, like the smoke starts collecting here, and after that get up. This is a bias. Also, we have some dissipation. We can increase it a little bit, um, maybe from 0 to, and see what happens. Now it's like disappearing at the end. And also we have some diffusion. This one we can increase also a little bit. And now the quality of the steam becomes chaotic just a little bit. And with this diffusion, it's not so simulates fast as previously. For example, if we don't have diffusion, the steam goes up. If we have some diffusion, it means the steams becomes have some slowy effect. Maybe something like this will be okay. The next we are going to change some velocity. We can add some swirl effect. For example, on the previous videos we can see some for magical smoke it's just like blowing, not not so straight, fast with this curly effects. It means if we increase this swirl, we will get these curly effects at the end. Something like this. Now we can see these small curly effects. Next, we are going to add some turbulence. Maybe we can increase the strength just a little bit for now, and then we can increase it more. And also we need to add some speed for this turbulence. Now we can see this slow magical effect. With this swirl and turbulence, and now this steam not go so fast at the top and have just like slow simulation with these curly effects. This one is just great for the magical smoke. If you want to increase the speed, you need to decrease the diffusion. And if we decrease the diffusion, our steams becomes a little bit faster at the beginning. And next, let's change our transparency. For the fluid effects, we will do a lot of shading effects. Here we can change the color, we can use some gradients, we can change opacity, we can change density for this fluid effect. By the change in transparency, we can make it more deeper or slightly transparent. Let's use some in-betweens. We can decrease the transparency and our fluids becomes um, more colorful. And next we are going to add some gradients. For the color, we can use magical colors such as violet, pink, blue, whatever you want. You can also use some black colors or something like this. And we can change the gradient. If we use some Y gradient, we can see the gradient as an example of previous videos. And we can change input bias and manipulate with the position of this color. Maybe something like this. Next, we are going to change some opacity. And for the opacity, we can even increase the density of this fluid or even decrease some. Let's delete these points and put it somewhere here. And also we can change it for the smooth. We can select these points and make it smoother. Let's make it smooth and add some in-betweens. At the beginning it should be 0, and then we can slightly increase and change how it's appear. Maybe we can use something like this. And also with the input bias, we can change how it depends on the density. Okay, next, every fluids have their own lighting. For example, in this folder, we can add some self shadow. With this self shadow, our fluid becomes deeper and have its shading and color, and we can use some real lights and ambient color, and we can change the ambient diffusion. For example, if we increase this, it will be more brighter, or we can change the ambient color let's just select self shadow and see the quality of uh, this fluid effect. Now we can see how it looks like and how it disappeared during the time. And next, let's save this result. If I'm going to create some disappearing effect, I need to animate our emitter. As on the particles, we have some basic emitter attributes, and we have this rate according to the percent during the time. We can increase this number if you need really powerful fluid. If you want to increase the number of these cloudy effects, you can increase the particle rate. And also we can animate this particle rate. For example, for disappearing magical effect, we need to animate this particle rate. For example, at the beginning it can be 0. Next, it can slowly increase this rate for the percent, and at the end it can be 0. Let's try this simulation if you want to create just a magical smoke effect with it disappearing. Let's set key. Let's start from the 0. We can set key here at the frame maybe 12, 20. We can increase it on the 3000. It can be rated until 90 frame, and after that on the 1000 frame we can decrease this particle rate to the 0, and now we can see this effect. It starts simulating, and after that it starts disappearing with these viral effects and blowing away uh, until it's disappeared or totally disappeared. And if you want to create some not ended steam, you can not do this animation, and your steam will be the same until the end. We can create some both variants. Let's continue with the smoke fluids. Let's save this scene as a magical smoke 2, and let's create first magical smoke, and after that I'm going to create my idea with this steam effect. But first let's create just magical effect with this disappearing simulation. Next, we also can animate bias effect in the dynamics, in the content details, in the density. We can change bias according to this animation. On the first frame, our bias will be around 10. Let's set key. On the 60 frame, our bias will be the same, 10, and on the 74 maybe our bias becomes 2. Let's set key, and let's check what we have. By this bias increasing, we have this fast beginning, and after that this smoke becomes disappearing with this viral effect. Um, this variant is pretty good, I think, and we can just add some noise here at the beginning, maybe for the 0, 1, And also we can change velocity scale. We can make it faster at the beginning by increasing this velocity scale. And this effect becomes, maybe I can not use this velocity scale because I don't like end of this simulation. Every time when you change some fluid effect, you need to start your animation at the beginning. It means you refresh the settings and everything you changed applies to the simulation and check it until the end. It takes time to set the really good result. That's why you can use some maybe play blast for seeing how it fast or how it's slow, and check your animation when you change something. Now I think it looks good. We can add some particles inside of this simulation. For example, here we can see some magical dust, and by using particle simulation we can add some magical dust effect here. And these particles uh, like sparkles in the fire. For example, if you want to create some fire steam, you can also use this particle system like a sparkles in the fire. Let's go to n particles and create some emitter. Let's put this emitter somewhere where we have fluid emitter. And first, we can see these particles not affected by this fluid. We should check the particles and our fluid effect container and go to the field and solvers. We need to use assign to selected. Maybe, yes. Maybe something, just 1 minute. I'm going to check. Let's see this assigned for selected. And now this particle starts, they now have constraint between fluids and particles. And also for the particles, we can change conserve to the 0 in the dynamic properties. And now these particles just in the fluid effect, the same as we want. And for the particles, we are going to change some scale for these particles. We can change the point size to the 1. We can change emitter number of particles rate. Maybe we can decrease this number. And also we can change the color of these particles. We can assign some new material for the particle selected. Maybe we can use Lambert and we can increase the V number of this color, vibrant. And also we can change the color for the yellow, maybe. Let's check on the render. And let's check the entire simulation and change animation for the emitter of the particles. For example, when our fluid emitter stops, we also need to stop our particle simulation. Let's go to the emitter for the particles and start use our fluid settings. For example, on the 70 frame, we can switch off our particles emitter. Let's set key for the beginning and the end set key, and maybe on the 70 frame we can increase the particle rate for the 0. You can play with these parameters according to your simulation and check how it goes. Maybe I can use different settings for this particle simulation. Let's break connection for this particle rate. At the beginning it can be 0. Let's set key. Maybe on the 40 frame or 30 frame it can be 3300, and the 7 maybe on the 100. Let's set key. After that we can decrease this particles number, and let's check the result. Now I think it's just a little bit better. Or we can use not so big numbers. Let's break connection and start again. Set key, and here will be 100. On the 90 frame, just keep. Here we can use some more numbers, and after that we can switch off this animation. Okay, it looks good, and also we need to change the lifespan for these particles. Now they live forever. Let's change it to the random range and keep it for the 3 seconds. Bless you. And the particles need to disappear with this smoke effect. Вы ставили lifespan, когда текст, да? Когда текст накрашится, потому что у нас есть initial state, и мы отключаем particle rate прям на 0. Поэтому она крашится, и там надо выгадать количество времени, чтобы они не умирали раньше, чем закончится анимация. Ну, не умирали полностью. Потому что потом, как бы они все умерли, а мы начинаем заново анимацию, и все, мама не понимает. А здесь у нас эмиттер есть, то есть, но мы его ставим на 0, но в целом сохраняет, то есть они наэмитились и дальше уже живут и умирают. И у нас здесь нет initial state, поэтому Майя не крашится. Но на текстах, да, на текстах у меня тоже крашилось. Okay, let's continue. Now we set everything, almost everything for these particles, and for better rendering, we are going to use some HDRI materials for the sky. We can use some textures for the background. Previously, we created some Arnold render skybox, ice sky dome light, and for the color of this ice sky dome light, we can use texture. And this texture called, where's my internet? This textures called HDRI. With these HDRI materials, it means we use not just colors. We are going to use EXR format of these HDRI materials. And it means we will get some light from these colors and from these textures. It's more natural, and we can use some daylight or night sky. It means you can use your own idea for this simulation. Maybe we can use some night sky. On this Polyheaven site, you can download without any registration the thousands of HDRI textures, and you can use these HDRI textures for better rendering in the Maya. And we are going to use this one. Let's download it. And also I'm going to share with you with these HDRI collections. You can use in rendering. And we created a sky dome light. And on the color, we are going to use our HDRI texture. Here we have this HDRI texture. Let's put into our folder. Now we have the background and we have light from this background. But the fluid effect is also dark. We need to add some more light. We are going to use the area light for lighting the fluid effect, for this additional light. And we are going to use some exposure and check how it looks. And also we can see the colors of our particles. And we can change some opacity in the fluid. Or we can change some transparency and check how it looks in the render. We can increase ambient brightness. Maybe it will help us to see light brightness. this light settings affects only in the viewport. Let's change our intensity of this light. Only with this Arial light we can light better our fluid effects. If you want to affect on the uh, how it render, you need to use additional lights for this fluid effect. And also in the fluid effect, I'm going to change maybe transparency more. If you're ready for the rendering, you can also increase this little bit base resolution to increase the quality, and also we have some quality in the settings, shading quality. We can increase it for the 2, and our fluid becomes more quality on the render steps. Maybe we can also increase the swirl effect in the content details. We also have some turbulence, we have some velocity. We can increase this swirl even more and see what happens with this magic smoke. I think with the swirl effect we have a really interesting example. And you can also check the position of the camera and find some good view of your fluid effect. Also, in the fluid settings, we have some textures. We can texture opacity with the Perlin noise, and it change its density. For example, if you want to render this fluid with some even transparency, with the chaotic transparency, you can use this texture opacity with the Perlin noise preset. And what is the difference? Now we can create the snapshot and switch off this texture opacity, and you can see this flat fluid without any texture opacity. If you want to add some interesting cloudy effects, you can use just texture opacity. If you don't want to use this one, it will be something like this. This one without texture opacity, and this one with this texture opacity. It's not affect on the settings of the fluid, it's affect only how it looks. It's like you use some texture for this fluid effect. Okay, I'm going to use this texture opacity, and let's check another render view. And now we get this interesting smoke effect. And on the next scene, I'm going to create my idea with this smoke steam. Okay, for this we've done. Let's open our previous scene. Before I'm going to save. And also, before we've done, let's check the play blast effect for this animation. I'm not going to save it. just for the preview. This play blast effect help you understand how fast your animation, because when you work with the fluid effect, some of you don't have really powerful computers, and you will see not actual speed. If you want to see actual speed of your animation, you need to check with this play blast effect. And also we have cache for the fluid. You can create the cache. And also you can put some planes here like a ground and assign some textures on this ground. But for the background, you can use some HDRI sky. And when you do some play blast effect, you will understand how much frames you need for this simulation, and you can maybe render not the full 500 frames, but just 250 frames. And now we can see the real speed of this fluid effect and how it's disappeared. And our particles still here. Maybe we can change lifespan, but it not affect more. Okay, let's see again. Uh, Fast start, and after that it's disappearing. Okay, let's save this result and go back to another variant of this simulation. For this variant, I'm going to uh, change and delete some animation for this rate. And also in the setting of this fluid, let's change in the content details. We can use decrease this diffusion and maybe decrease bias. Now just increase diffusion, increase biasing. And also we can use field and solvers and initial state set for selected. Or maybe it's possible. We can also increase the swirl for this effect, and let's change the color of this fluid. We can use some maybe orange to the dark. Something chemical. And I'm going to model this tube. Let's select faces, little modeling here. With extrude inside, we can create some tube here. And we can find some position where to put. Maybe change some scale. And also we can use some passive collider. And I think this fluid effect also can collide with the objects. And also we can find some night sky. Maybe we can use the same night sky. on the color, we can use EXR format. Let's open this one. We need some textures. Let's assign some material. We will use some Lambert materials, and we can find some concrete material here. I'm going to change place the texture and repeat this texture 5 times. And we need some orange materials. We can create the better materials with the Substance Painter, but we don't have really much time. That's why we need to. We can use and divide these materials. And we can use some special polygons and assign orange material above them. Maybe something like this. And assign new material on selected faces. And we can use some orange here. And also we need maybe we can change the size of this emitter. Here we have collisions, but we have rigid body here, but this fluid intersects these collisions. Maybe let's check render. And also every fluid has incandescence, and we can change it for the Y gradient. If you use incandescence, it means uh, you don't have light because this fluid becomes warm. If we change this incandescence to the temperature, but we don't add some temperature, we can see this fluid cold and don't use this gradient for this incandescence. Maybe we can use just previously some real light. Here we can use even less transparency, and self shadow we have. Texture we don't need for this situation. Maybe I'm going to use some incandescence, and we can use some white color, something like this, just for the small brightening. We can also change the volume of this emitter, and we can change the scale maybe and put. I think this density is powerful enough. We can We can change the radius of our fluids. Okay, let's check this position from our camera view, something like this. And also we have container and we have boundaries. If we have after resize, sometimes boundary can be rendered and we can change it on the after on this container properties. Uh, we can not use these boundaries anymore, and if we switch off these boundaries, sometimes on the render we will not see uh, how fluid faced with these boundaries. Okay, maybe something like this. Here we have this boundary. Where we can see this boundary. Well, because I'm switching off this oh, We can increase the resolution and sub-steps margin. Okay, we have the base resolution, we have after resize. And let's try maximum resolution for this one. And let's see. I hope this will work. Now we can see these boundaries. Oh, if you increase even more, maybe it will help. If you change after resize resolution and margin, your simulation becomes slow, but on the rendering the same. Okay, maybe. Maybe we can increase the size of this container also. Let's save this and change. Restart Maya. Now it's work. Maybe it was something with Maya. Let's check position. Now it renders well. Maybe sometimes restart helps to to solve some problems with this fluid. Let's check the simulation. Yes, there is no boundaries here, and we can render this out. But also let's check some fluid. We can check collisions with the plane and put it here, and make some passive collider, and let's check how fluids affect with the collisions. It's not affected. Make collide. Okay. We just simple can select this one, fluid, and cylinder, and go to make collide. Now this works. Or maybe we can also try plane, put it here, and make collide. Now it's, yes, the collision works. If you want to use some collisions, you can make collide them. Okay, I think it's next steps is just render this out, or we can use some play blast effect for the simulation, or maybe we can also change some diffusion. Dissipation. Yes, if you increase this dissipation, your fluids, even emitter is works, dissipate after time. If we decrease this dissipation, the fluid becomes bigger to the infinity. And you can play with this dissipation effect. And also we can use some tension force. Let's try to add some tension and check what we have. Okay, let's decrease this tension force and let's go and make some play blast for this effect, and we're done for today. Mhm. Okay. It's almost done with this play blast. Few more frames and we can see the real speed of this simulation.